If it is vacuum, if the charges are placed in vacuum, then we say epsilon naught. This is permittivity
of air.
Of air or of vacuum, accurately. Okay. Permittivity of free space, we say. This vacuum is, we normally call free space. Permittivity of free space. Okay, this permittivity of free space has a value 8.85 into 10 to the power of minus 12 Coulomb square, Newton minus 2, meter minus 2. Okay, yeah, Coulomb square, meter square, and Newton minus 1.
Okay.
Yeah, Newton minus 1, meter minus 2. Okay, sorry. I'll just write again. Coulomb square, Newton minus 1, meter minus 2. This is the unit of this. While how can you have this? Radius. This R is not the radius. If you have got a plus, okay, if you have got another one here, the distance between them is R here. It's not a radius here, okay? You can give the, you can give the, no problem, but in your textbook it is R. That's why I have given R. Any letter you can give X, doesn't matter. But okay, then you put D and write it is the distance between them. It's not the radius. In your book it is radius. R is used for the distance. Yeah, sorry, in your book it is R. Okay, so it's the distance between them. So this is important. You can easily remember this number. This can be approximated to 9, right? This is 9. 9 into 10 to the power of minus 9. Easy to remember. This value you often have to use. This value rarely only we need. And what is the unit of this? If this is a unit of epsilon, this is a constant. What is the unit of K? K unit will be inverse of this. Coulomb minus 2, Newton meter square. Okay. Okay, so this is the magnitude. This is how you find the magnitude of the force. How will you find the direction of the force? Direction of what? Please understand, direction of the force between them. If they are of same charge, they will get repelled, right? If they are opposite charge, they will get attracted. They will get repelled, means will be pushed away. Attract means it's like this. Whether attraction or repulsion, the direction, the force will be along this line. Along this line. So how do we write that? It will be along the line joining, along the line joining the centers of the two charges. Centers of two charges. Is that understood? The force will never be over here in this direction. The force will never be in this direction. Force will be always in this point. So this point you have to remember when we'll do net forces. So this is the magnitude. This is how you find the magnitude. This is how you find the direction.
Okay.
Okay. And this direction, how will you find? Since it's okay, remember it's a vector quantity. This direction is found if there are multiple charges. If there are two charges, it is easy. What if there are 3 charges? Okay, if multiple charges, that means more than 2 charges, if multiple charges, then this net force, okay, that means the sum of all the forces, we will write F net, is found by vector addition. What do you mean by vector addition? What do you mean by vector addition?
Components adding together.
2 methods you have learned?
We have to use triangle rule or?
Exactly. Triangular law of Parallel. Then I'll give you 3 or 4 charges. So question 1. Assume that you have got, say, some easy numbers. You have got, say, a plus charge which is 10 coulomb. You have got another plus charge which is, say, 20 coulomb. Okay, say again 10 coulomb, enough, 10 coulomb. Separated by a distance of say 4 meters. Okay, now you have to find out what is the charge at this point. Say this is 2 meters from this charges. Let this point be, say, A. Okay, 2 meters from here, say B. This is also 2 meters. This point is B. What is the charge at this point? What is the charge at this point? Will the charges be equal? Will the charge at A or B be equal? This is 2 meters from this, 2 meters from this, and this point B is 2 meters from this. Calculate the net force at A and B. Okay, magnitude, how will you find? By the formula. And direction. Okay, yeah, I'll show you. I'll show you one. So the force at A due to this charge, let this be charge 1. This is charge 1, this is charge 2. Okay, because both are 10 coulomb. 10 coulomb, it is different. Okay, that's why I'm just mentioning. Okay, let this be 20 coulomb. Okay, so force at this point, the force at this point due to this is in which direction? It's a positive charge. What is the direction of force over here? Is it to the right or is it to the left? How do you know? Because, okay, no, wait. To understand the direction, the easy way to understand the direction is to use the electric field direction. Electric field, I told you, electric field around a positive charge is in which direction? Did I do that? Okay. Then I will do that. Then if you do, this is easy to do. What is electric field? What is electric field? What is electric field around? Electric field around a charge. Okay, always electric field is caused by one charge and it is around that charge. What is the electric field around a charge? It is the space around a charge where space around a charge where what is the condition? Another charge will experience a force. If you place a second charge in that vicinity, will it experience a force or not? Whether big or small, however big or small the force is, will it experience it or not? That is called the electric field. For example, if you have got a positive charge, a space near to it. Okay, a three-dimensional space. Three-dimensional space. Three-dimensional space. That means like a football. Like a football. The charge is placed at the center of the football, and that space, that envelope covering that. Okay, it's not just in one plane, it's in a three-dimensional one. And this outer edge, okay, it's very difficult to define, but it gradually decreases to zero until infinity. But you can imagine that it's a three-dimensional space near a charge where another charge, if you place, let this be Q, let this be say capital Q, a big charge, and I placed a small charge, a positive charge I placed over here. What force, if this has to be the electric field, if this point has to be in the electric field, there must be a force on it. Okay, so if another charge placed near, if that charge experiences a force, then we say it is placed in the electric field. If you place a charge over here and if the force is equal to zero, then this is out of the electric field. All right. Now, you know that, okay, now what is the direction of the electric field around a positive charge? Electric field around a positive charge is radially outward. Electric field, the direction of the electric field can be found by electric field lines. Electric field lines. Okay, so this will tell you the direction. For a positive charge, it is radially outwards. Radially outward means from here outward. So it may be like this, it may be like this, like this. The number of lines will depend on how strong this is. If this is very strong, then you will have more number of lines, but all lines start from the center. Similarly, for a negative charge, how will the electric field around a negative charge? Again, radially outward. Okay, radially inward this time. Inward. Okay, so this is called radially outward. This is radially inward. This you remember. Okay, so that means electric field lines will start from positive, end on negative. Okay, so if you place a positive and a negative charge closer, what will happen? If this negative charge were in there, it will be radially outward. But because of the presence of this one, this line which would have been going that way will bend and converge on this. Okay, so this clearly shows that this electric field line starts from positive, end on negative. So this you always remember. This direction from positive charge, it goes away. Negative charge, it comes towards. That is why just like a North Pole and South Pole, you will have electric field like this. But here and on, it comes towards negative. This is negative. But since it is positive, here it goes away. So this shows that electric field lines start from positive and end on negative charge. Understood? Okay, so this is what you have to remember for all drawing electric field lines. Only one point. They start from positive, end on negative. If so, if you have got two parallel plates, this is positively charged plate, this is negatively charged plate. What is the electric field between them? What is the electric field? What is the electric field between them? Okay, so the electric field lines, as we said, it starts from this positive plate and it ends on negative. Okay, so and this will be parallel equidistant lines and the center of this. So this kind of electric field is called what? Uniform electric field. Okay, if they are, what is the condition for uniform electric field? Parallel equidistant lines means uniform electric field. Is the electric field around a positive charge uniform? No, because they are not parallel. They are not equally spaced. Is the electric field around a negative uniform? No. If the electric field are between two opposite charges uniform? No, they are not parallel, they are not equal distant, but electric field between two metal plates in the space here. Okay, between two charged plates, two oppositely charged plates. Two oppositely charged plates, you will have a uniform electric field. But this electric field will be uniform only in this, but here in the edges it will be curved. Okay, here it will be curved, but in the center it will be uniform. Clear? So now you know the direction of the electric field. Now from the electric field, how will you know the direction of, okay, for example, at any point, at this point, what is the direction of electric field? You draw a tangent. Okay, the tangent will tell you the direction of the electric field from the electric field. That is the significance of electric field. Okay, so electric field line is a line which starts from positive and end on negative. It shows the path of a unit positive charge when moved around a charge or system of charges, and the tangent at any point. Okay, this point will not. Tangent at any point gives the direction of electric field at that point. They do not intersect. Okay. I will give you the properties of it in the group. Okay, there are many properties. I'll put it in the group. Please copy them down later. Properties of the electric field lines. I will give you and give it in the group. What is electric field? And the properties. They do not intersect. Why? Why? Because if they do intersect, assume that they intersected here. I am drawing another line which is like this. I am drawing one like this. So here they intersected. If it intersects here, that means there are two possible directions, one this way, one this way. If any point, if the electric field line intersect, that means that at that point there are two directions, which is impossible. Okay, electric field lines do not intersect. Okay, fine. So now you know what is the direction of the electric field. The direction of the force is same as the direction of electric field on a positive charge. That also you can understand. Okay, for a positive charge, the direction of force and electric field are same. Okay, so now having known that, let us come back to this. Let us come back to our question. Okay. Can you see? Yes. This was our question, right? Let the force at this point due to this 10 coulomb be say F1 or it's a F10 coulomb. Force due to 10 coulomb is equal to. It's in which direction? This is the positive charge. Positive charge means, okay, now what you have to assume is that the point, at the point you are keeping a test charge. A test charge is always positive. So this positive and this positive will repel. So it is in this direction. Let that be F, say 1, F1. F1 is equal to F due to 10, which is in this direction. Did you understand? Huh? Now, at this point, now you forget about this. At this point, what is the force due to this charge? Okay, let that be F2, which is force due to 20 coulomb, which is in which direction? This is positive. I told you test charge is also positive. So positive and positive repel. So it is in this direction. Here it is in this direction. So if the directions, assume that you have got an object, you have got one force in this direction, another force in this direction. F2, how will you find the net force? If you have got two forces in the opposite direction, how will you find the net force? Do you add or subtract? Subtract. This is vector law. Same thing you have to do it over here. Okay. To find the vector addition, to find the sum of the forces, since the directions are opposite, you have to subtract. Whether positive or negative. So the positive or negative is indicated by this direction. So no need to put additional negative or positive. Okay. So now what is the magnitude? K Q1 Q2 by R square, which is, how much is K? 8.99 into 10 to the power of minus 9. Sorry, 10 to the power of 9. Okay, now this is not minus, this is not plus. 8.99 into 10 to the power of 9 into, how much is Q1? 10. How much is Q2? 20 divided by, okay, Q1, yeah, Q1, Q2 divided by what is the total distance? 4 meter, 4 square. No. Okay, at this point you are fine. Okay, fine. So this is the total force between them. Total force between. Now at this point, what is the total force? Now this distance, now this one has a charge of say 10, and this one you have to, now I'm going to do it in two simple steps to understand what is the net force. This test charge is say 1. Okay, this charge that we place here is 1. And Q into K into 10 by this one. So this is F1. Similarly, what is this one? K into Q1. So Q1 is 10. Okay, so this 8.99 into 10 to the power of minus 10 to the power of 9 into, this is this one, 2 into 1 divided by 2 meter, 2 square. Because you want to find over here. Okay. So now this you will get an answer. This you will get an answer. Now what is the net force? You know that this is bigger than that one. Since they are in the opposite direction, the net force is equal to F2 minus F1, and the direction will be in the direction of the bigger one. Understood? So here, this charge which you are placing, you can remember test charge. What is a test charge? Test charge is a charge which magnitude 1, okay, 1 coulomb. Test charge is always positive 1 coulomb. Unless they say it's a negative charge, test charge is always positive 1 coulomb. It is used to find the direction, find the electric field, etc., etc. Okay, so that I'll teach you more when I teach you about the electric field. So we are not finding due to this. At this point, what is the total? Now let me give you another question. So that time it will be more easy for you. More easy for you. Okay, assume that you have got, say, a plus 10 charge. You have got a plus 20 coulomb, and you have got you have got a plus, again plus, okay, again plus, say 15 coulomb. You have got 3 charges. You have got 3 charges. You have to find what is the total charge due to this. Sorry, what is the total force due to this one? Okay, if you have got multiple forces, how will you find the charge on this? So for this, what you do? Okay, first of all, you find, now assume that you want to know what is the force at this point due to these two. Okay, so let this distance be, say, and now so say 2 meters. Now instead of giving you values, let me give you like this. Let this be Q1, let this be Q2, let this be the point. At this point, what is the force between this? And let this be a charge Q3. Okay, so what is the total force at this point due to this? Now, this is positive, this is positive, this is also positive. So if they are positive, then what is the direction of the force? The force will be along this line. Since they are positive, they repel each other. So this is the direction of one force. Now, and how much will F1 be? K into Q1 into Q3 divided by, say, R13, 1 and 3. Okay, say R13 square. In which direction? This direction. So that is this is the magnitude, this is the direction of that force. Similarly, force 2, that means force on this one due to this charge will be K into Q2, Q3 by, let this distance be R23, between 2 and 3. R23 square. And this is in which direction? Both are positive, they repel. This is in this direction, F2. Okay, this is in this direction, this is in this direction, because the line joining them, that is a principle. Force between two charges will always be in the line joining them. Between these two, it is like this. Between these two, it is like this. Now, you've got two forces. How will you find the resultant? If in the earlier case, we simply added or subtracted. If you get the two forces in the same direction, you add. If you get the forces in this direction, you subtract. If there is an angle between them, what will you do? What will you do? Net force is equal to vector addition of F1 plus vector addition of F2. And how will you find the magnitude? square root of, remember the cosine rule? A square plus b square plus 2ab cos theta, which is f1 square plus f2 square plus 2f1 f2 cos theta. This is how you find the magnitude. F1 you can find using this, F2 you can find using this. Then okay, I'll tell you the resultant R is equal to square root of A square plus B square plus 2AB cos theta. Use cosine rule for magnitude. How will you find the direction? You try constructing a parallelogram. This is the resultant. This is the direction of the resultant, F net. This very rarely comes. Okay, this type of questions very rarely comes. But you do understand that this is the way to find. Don't simply add or subtract. Use vector addition. Magnitude we found by this formula. Direction you find by vector addition. It is easy to use parallelogram law in this case because you get these two and the angle between them also you get. So you can find that. Okay. So this they usually ask you, and also they may ask you what is the total force at this point. Many times they will give you only with the two forces. Okay, force between them, two charges. But in case if you get three charges, more than two, then this is the way to do. Okay. So now, what is electric field strength? We have learned what is electric field. Now, what is electric field strength? Electric field strength or electric field intensity. This is another important quantity which is represented by the letter E, and it is a vector quantity. Electric field intensity. What is electric field intensity? This shows the strength and direction of the electric force. Strength of the electric force which a charge experience. Okay. The strength of the electric force at a point is called electric field intensity. Strength of electric force. Strength of electric force at a point in the electric field. You know what is electric field? What is electric field? Space around that. For example, if this is a positive charge and if this is the electric field, this whole thing is the electric field. But if you have got a point over here, say A, and a point over here, say B, then which point will have more electric field strength? Which point will have more force? A, because it is placed closer. That means it depends on the distance from the charge. So this electric field strength is defined as the electric force a unit charge experiences. Okay, very, very important formula. Electric field at a point. Okay, electric field. Now, this electric field intensity, we may say in short electric field sometimes, but it's actually mean electric field intensity. This is actually at a point. It's a property of a point due to a charge. Let this charge be say capital Q. This charge is causing the electric field. And at a point, this electric field is equal to the force which experienced by charge. For that, assume that we are keeping a small test charge, say Q over here. Okay. If you have got a charge Q, and this is the main one which is causing a large charge, capital Q. So what is the electric field formula? How will you find? First of all, you have to find the force between these two charges. What is the formula for force between these two charges? K into the source electric force. Always revise and learn because these quantities are interrelated. What is the force formula? K, say capital Q is the one charge, small q is the another charge divided by r square. This is force. If so, what is the electric field due to this one? This is equal to K Q by R square. Did you get the relationship? Okay. So when you divide force by one charge, test charge, you will get this one. So what is the relation between force and E? What is the relation from this? What is force? Force is equal to Q into E. Very, very important formula. This is how you find the force if you know the electric field. This is the way to find the force if you know the charges. Understood? If you know the charges and the distance, this is the formula. If you know the electric field and then the charge, this is the formula. Okay, so please compare and learn always.
Okay.
Okay, so this formula for E is equal to F by Q or F is equal to Q into E or EQ, very, very important. Now here also a common question that they ask is, and the direction of the electric field, we know, direction. This is how you find the magnitude, direction of E from positive away, negative towards. This is the only thing that you have to remember. Okay. Now let me give you a question. Okay. You can calculate the electric field, the net electric field, and the force acting on a charge placed at the, force. Okay, first we find the electric field. Electric field at, say, P, at the point P. This is the question. You have got a 10 coulomb charge. And here you have got another 10 coulomb charge separated by a distance. This is 2 meters. This is 2 meters. Okay. This is a point A. And again, let's find out another point, 2 meters from here, point B. What is the electric field at A and B? Okay, one I will show you, then the other questions you can do it on your own. First of all, you have to find the direction. Direction of electric field at this point due to this one is in which direction? Towards, sorry, to the right or to the left? Say E1. E1 is the electric field due to this one, the charge 1. Okay, how much is this? What is the formula? E is equal to K Q by R square. So in this case, K into Q is 10 by R square means 2 square. That means 10 K by 4. What is the unit of electric field? Find out. From this you get the unit of electric field from this formula. Unit of force. Unit of force, any force. Electric force is just like all of force. Newton, unit of charge, Coulomb. So there are two units. One unit is Newton per Coulomb. Okay. So this much Newton per Coulomb is the charge, is the electric field. Due to this is E1, electric field at this point with the first charge. Similarly, what is the electric field direction at this point due to this one? Again, this is positive. You have to assume that the test charge that we keep always is positive, positive, positive ripple. This is the direction of electric field. Okay, this is the direction. Now, this one is in this direction and E2 is in this direction. And what is the magnitude? Again, KQ by R square, which is K into, this is also 10 by 2 square, which is how much? 10 K by 4 Newton per Coulomb. Which direction? This way. Now you compare these values, they are equal. Okay, this is also 10K. I did not put the multiply by 9 into 10 to the power of 9, but they are equal. So this is also K, this is also 10K, they are equal. So what is the sum of them? Sum of them, net force. What is the net force? Very good. Therefore, E net is equal to E1 plus E2. They are of equal magnitude, but the directions are opposite. Therefore, 0. Understood? But if you had to find at this point, which is 1 meter away, will the electric field be 0? You can do that as homework. Calculate electric field in net 1 meter from here. Okay, I'll give you the question. This is 10 Coulomb. This is another 10 Coulomb. Total distance is 4. This point is 1 meter away. Say point P. You have to find the electric field in net at this point. Can you do this as homework or should I do it now?
Yeah.
So what is the first step? Step 1. Find the directions. Okay. Then step 2. Find the magnitudes. Step 3. Add or subtract or use triangular or parallelogram law. That's all. Okay. Now, if the electric field is 0, if I ask you, what is the force? If I own, assume that a 20 Coulomb placed at this point A. If I keep a 20 Coulomb charge at this point A, what is the force this 20 Coulomb feels? This is the key point. Electric field at A, you got it as 0. If you know this is going to be easy. Because what is the formula for force? Force is equal to charge into electric field strength. So charge is 20, electric field strength is 0. Therefore, force is also 0. So this you remember. Because there will be questions where you will be asked to find what is the force. Okay. Or you have to find the point where the force is 0. you have to find the force is zero. I'll give you another question for that. This is an easy one. Okay. Now the force will be zero if the electric field is zero. So you find which point has electric field zero, then you can find that same location. Now let's find a B. Calculate the electric field net at B. This is the question. Okay. This is the question. What is the electric field net at B? So in this one, again, you find the direction. Electric field 1, which is due to the first charge. This is positive, this is positive. So this is in which direction? Positive, positive in this direction, right? This is E1. Okay, to the right. Because this positive and this point, you have to assume that there is a positive charge of 1 magnitude kept at that point. So the force here is E1 to the right. What is the magnitude? K Q by R square, which is K into what is Q? The electric field that is due to this 10 coulomb. So K into Q by what is the distance? This full thing is 4 plus 2, because at this point I'm finding this is the point B. Okay, so from due to this one I'm finding. So 4 plus 2. 4 plus 2 means 6 square. Which way? This way. What is the electric field E2? That means electric field at this due to this one. This is also 10. So K Q by R square, which is K into 10 by, now this time what is the distance? No, 6. From this one it is 6. Now I am finding, you have to find the field by individual one, then you add. Now the electric field at this point due to this one, what is the distance between them? 2 square. Okay, which direction? So, hello, Hassan. Did, did he did he leave? The class is not ended. We started at 4, right? Yeah, 30 and then 30 and then I left a little while, right? So I have to do that also. 30 more, yeah. Yes. Now tell you to join soon. Yes. Okay.
I'm here. I'm here.
Okay, so let's continue with this. What are we finding? We are finding the electric field at this point B due to this. Electric field at this due to the 10 charge is this much. Electric field at this point due to the 10 charge. Second 10 charge is this much. What is the direction of this? This is also positive. Our test charge which we are placing here is also positive. So positive, positive repel, and we get second one also in the same direction. Understood? Understood. Here, why did we subtract? Because they were in the opposite direction. Here we have to add. There is no other option. Okay. So this also tells you that if you have got same charges, electric field will be zero between the charges. And outside the charges, electric field will never be zero, will not be zero. Because outside, whether here or here, you will get it in the same direction. So you will have to add outside the charge, outside. Okay, if the charges are of same type. Okay, infinity, the electric field will be zero. That's fine. But just outside this, they will be in the same direction. This also is in the same direction. So what you have to do? Electric field in net is equal to E net is equal to vector addition of E1 plus vector addition of E2, which is what is common here? 10K. 10K by into 1 by 6 square plus 1 by 2 square. And you find the answer in this direction. This is how you find the net electric field. Is that understood? Yeah. 10 common because in both places I had it 10. Huh? What is only different is this one. So depending on the situation, what you can sometimes these values will be different. You use your calculator to get this value. Use your calculator to get this value. Then you simply add. Now, if they ask you what is the force, what is the force on, say, some other charge? I am placing some other charge. Which charge will be put over here? 20 coulomb. Force on 20 coulomb placed at B. How will you find? Force is equal to this 20 into electric field at this point, E net, which is equal to 20 coulomb into this answer. This many newtons. This is a common question. Huh? Now, Now I'm giving you a question in which both you can find combined. If you know the electric field in net, you can find the force because force is equal to charge into electric field. Okay, so this is another charge if I placed at this point. So what the easy way to find the force on a charge is you first find the electric field in net electric field, then you multiply with that. Okay, this is the easy way. Now, shall I give you a homework? This homework is plus 10 coulomb here minus, I'll give you a different number, okay? Minus 20 coulomb. Minus 20 coulomb separated by a distance of, say, 6 meters. You have to find the electric field in net and force on another charge. Let the charge be 30 coulomb. Okay, placed at, say, A and B. A and B. Where is A? A, let's not take it in the center. Let's take it somewhere here. This is A, and A is, say, 2 meters from here. Okay. B is over here. B is this. This is also at a distance of, say, what distance? 3 meters. Any distance you can put. Okay. Did you understand the question? This is a homework for you. Okay. So what you have to do? First you find the E net at this point. How will you find the E net? Think about the charges. If you get the force, the electric field in the same direction, you add, opposite direction, you subtract. Here you tell me, should you add or subtract here to find the net electric field? Should you add or subtract? Huh? Okay, let us see. This is positive. Positive charge is always away this way. This is negative charge. Negative charge is towards. So both are in the same direction. So you add. Very good. At this point, due to this one, this is positive. So positive charge is away. This is negative. Negative charge will be towards this, towards the charge. It is here. This will be. Understood? So here you have to subtract. Similarly, if I take a point here, C, okay, this is also 3 meters. You have got a lot of time. You work out at C also. At C. This is a 3 meters, then you will know the difference. 3 meters. Here again, what is the direction? Due to this positive, it will be away, E1. Due to this one, it will be this way. Here also, you subtract. Okay. So this is how you find. Why do we use these arrows to understand whether you have to add or subtract? Because electric field and force is a vector quantity. That also please note down. We add for electric field in net or force in net because electric field strength and force are vector quantities. Vectors. Okay. Because later, now after this, I'm going to teach you something that is scalar, for which this is not the way. Okay, so remember one thing. Here this is negative charge. So don't put this negative for the values here. Okay, here I gave you with both positive. Here I gave you negative. So don't put this negative in this one, because this negative is indicated in our arrow. So don't put the positive or negative for charges. That also you write. Don't put positive or negative for electric field or forces. Just put what? Just use direction. Okay. If you follow this, you will not go wrong. If you're going to put this plus and minus plus the direction, you will definitely go wrong. Please write that point somewhere strongly. This is for each one, force and electric field. Huh? Understood? No. I'm going to continue. Okay, now is it understood? Here for positive and negative, we are using direction. Don't put this sign in your calculation. Now, another type of question which you will get in connection to this is this one. Write the question down. Write the question down. 2-point charges. 2-point charges. Say Q1 is equal to minus 1.0 into 10 to the power of minus 6 coulomb. And Q2, which is, it's not here. Okay, Q2, which is 4 into 10 to the power of minus 6 coulomb, separated by 3 meter. Separated by 3 meter. Find the position where the electric field net, or find the position where zero field location, or find where the electric field net is zero. Zero electric field, zero field location. This is called zero field location. Okay, zero field location. Let this be Q1. Let this be Q2. This is minus charge, 1 into 10 to the power of minus 6 coulomb. This is 4 into 10 to the power of minus 6 coulomb. They are separated by 3 meters. Did you understand? Okay, see, you are given 2 charges. You have to find a position, exact position, so many meters from this charge or this charge. You have to say where, when you add the electric fields, you should get 0. Earlier, we found how to calculate the net electric field. Now, when you calculate the net electric fields, you should get an answer 0. Okay, this is an important question. For such questions that you can easily do without for doing it quickly, you can use these clues. Number 1, in net will be 0, always near or around, near smaller charge. Smaller charge means smaller magnitude. So will it be near Q1 or Q2? Huh? See, this is the condition. Q1 because it is 1. Don't think about the positive or negative. This is 1, this is 4. So, the first clue is you have to find a point near smaller one. So, you can forget around this one. Okay. Second condition, what we did earlier. If now, what did we do earlier? If they are same charges, if same charges, that means if both are positive or both are negative, where will the field be 0? Is it between them or away from? Between them. Why? Because here one will be in this direction, other will be in this direction. So only in between there is a chance to become zero. So if the charges are same, then E net will be zero between the two charges. Okay, so that means you need to look only in between. You don't have to try for this region or this region. Fine. If opposite charges, where should you look? Opposite charges. Is it in between or outside? Outside. Because if this is positive, this is a negative. Now here they will be in the same direction. Now here, it may be here or here, depending on the first condition. Okay. For example, here it will be this way, and due to this one it will be this way. So this is one possibility. Either you look here or here also. This is one way, this is one way. Either you look here or you look here. But you can also still sort it out if you remember this law. So if you look around the smaller charge, if it is same charge, you look closer to the in between. If it is as the opposite charge, then you look here or look here. Understood? This is a clue. Very, very, very useful clue. Now apply that. Apply. Okay, let's do two negatives. Two negatives. Where will they be? Now here you find. What is the force at this point you do to this one? This way. Right. They are repelling, that's true. But the electric field at this point, electric field due to this negative at this point is towards negative. This also towards negative, so it will be in this direction. Same as positive, same as positive. They will be in the opposite direction. As I told you, same charges, you have to look in between the charges. Okay. Now using these two, spot out where exactly or near to which charge, inside or outside, you have to look. Applying the first condition, you will know that it is around this. Okay. Applying the second condition, is there of same charge? No, one is positive, other is negative. So it is not in between. Therefore, it will be outside and it will be closer to the small one. You don't have to look over here. You can find a point and again which way? In this line. In this line, somewhere in this line, near outside this point. Let this is the point where electric field is zero. Okay. Now what you have to do? This is the first thing. First, step one. Step one is locate. Locate the point using the clues. This is step one. Step two. So electric will be zero if the E1 is equal to E2. Okay. For example, E1 will be in this direction. E2 will be in this direction. So E net will be zero if E1 is equal in magnitude to E2. Okay. E1 will be zero only if E1 is equal to E2. Now you write the formula for E1. E1 is K into Q1 by, now what is the distance that you assume? That's the question. You assume that this point is at x distance, x meter from this one. This is the point which is x meter from the smaller charge. This is what you have to assume. So assume that the point is at x meter from -1 into 10 to the power of -6 coulomb. This is what you have to assume. And you have got the point. So now you apply this. E1 is how much? K into Q1 by, what is the distance between this? X. X square should be equal to K into, what is the second charge? Q2 by, what is the distance between this point and this point? This is the point. What is this distance? Hassan? 3 plus x. Very good. This much is 3. This is x. Okay. Now you put in values. K, no need to put. K into 1 into 10 to the power of -6 by x square is equal to K into Q2 is 4 into 10 to the power of -6 by 3 plus x whole square. Now what to do? Now what to do? What is the easy way? Take square root on both sides. Okay, take square root on both sides. When you take square root of this, what will you get? K into 1 into 10 to the power of -6 by x square, the whole square root, because we want to get rid of this square. Square root of K into 4 into 10 to the power of -6 by 3 plus x, the whole square. Now you cancel 6 and 6k and all those things can be cancelled. Square root of 1 is 1. Square root of x square is x is equal to square root of 4 is 2 by 3 plus x. Now what to do? Solve for x. Cross multiply. 3 plus x is equal to 2x, which means 3 is equal to 2x minus x, which means x. So this point x is equal to 3 meter. Okay. So this distance is 3 meter. 3 meter. So finally you write E net will be 0 at 3 meter to the left of -1 into 10 to the power of -6 coulomb. This is the final answer. Okay, so please do this question now. Because this is important one. Do this question. See, that is the condition. The question is what? Find a location where E net is 0. Yeah, then this is not the way. This is the way for finding 0 field location. Okay, the electric field will be 0 if only the magnitude of E1 is equal to magnitude of E2. Okay, now you do this. Very important one. That's why I'm making you do it over here. Then I will give you homework questions. Hasan, have you understood?
Yes.
Please do this one now. This is the question. I think you have already written down the question. Draw this diagram. Okay. Okay, so but you will have to do it without seeing this in your copybook. Okay. Now shall I give? Okay, since I'm giving you a copy of this, but I want to see it in your copybook. Next class I will give you a
Yes,
test
miss.
of this one. Tomorrow is which day? Wednesday. Oh, okay. Now are you free on Fridays?
No, miss.
It's the same time. Are you free?
Thursday?
Friday. No. Saturday. Okay, Saturday.
Yeah, Saturday, I'm sure. Yeah, Saturday. Okay.
Okay, so next class I will give you on Saturday. So Saturday and Tuesday we'll have classes. Okay. Pardon me? That I will tell you, maybe 4 o'clock. Because if it rains here too much, then there will be a lot of noise. That is why I am just making a small. Do you have any class on that day?
On Saturday?
Yeah,
I think I have a class. That is at 10 a.m.
10 a.m. Okay, so 4 is up for me also. 4 or 4:30 like that, around that. Okay, so we will, Now I will give you another question. Shall I give you another question now? Another one. If you've got time, let's do it now. Do you have time now? Okay, then if you don't have time, then you can do it homework, but you write this question down. Very, very important question. Where is the electric field? 0. Earlier I gave you with one positive. Okay. Find where the electric field in net is 0. Also remember, at that point force also will be 0. Okay, so to find where the force is 0, just find where the electric field in it is 0. This is the point. So this is Q1. Q1 is a 80Q. Q1, this is Q2. Okay, fine. I'll write like this. This is minus 81Q. Okay, instead of giving 10 to the power of minus 6 and all, I'm giving like this. Minus 81Q. This is one charge. This is another charge where this just minus Q. And the distance between them, I will say 6 meters. Okay. Earlier I gave you different charges. Now I'm giving you same charges. Find out where electric field is 0. Okay. First of all, use the clues. Is it in between or outside? Same charges will be this way, other will be this way, between. Very good. Now, if you have to look near which charge, 81 or minus 1? Minus 1 because this is smaller charge. So, after doing that, what should you do? You know that it is in between, so that means it will be to the left, never to the right. So here you assume that this is the point, say P, which is at a distance x. Okay, so this is how you locate. So you assume that, and that you have to write. Assume that electric field in net is equal to 0 at P, which is x meter to the left of minus q. So this is most important. Finding the location is most important. Okay. Then what should you do? At P, you write E1 is equal to E2. So how much is that? K into E1 is minus, don't put minus and all, just put 81Q by what is the distance between this? If the whole thing is 6, what is, if this is x, how much is this? Hassan? Very good. 6 minus x, the whole square, should be equal to k into, you don't need to put the value of k into 8 into 10, etc., because we are going to cancel them out. Into q into, what is the distance between this? You have already taken x square. Now you know what to do. All right. Okay. Now you know what to do. Find the square root and get the answer. So these two questions, you do it without seeing and send it to me today itself. Today.